Videos about Lewis acids and bases. So in the question, they tell you that there is a coordinated bond. And a really easy way to figure out what to look for is to actually look at the answer first. So in the answer, they mention Lewis base and acids. So we know that the concept of this question is how to identify Lewis acid and base. Let's look at this compound in an example. So boron's bonded to 4-fluorine. So we only need to look at one of the bond to figure out which one is a Lewis acid and base. And so to see this more clearly, we can write the compound and the atom before it is bonded together. So we would have an equation looking like this. What's missing from this diagram are electrons, so we can fill out the valence electron. A pair of electrons from fluorine, let's signify that as red, has been donated to boron. And we know this because boron electrons, there are no available electrons because all of them are bonded to the other 3 fluorines. So let's signify boron as blue. Between boron and fluorine, it's a coordinated bond because we know that both of the electrons belong to fluorine. Boron would be a Lewis acid and fluoride would be a Lewis base because a Lewis acid accepts a pair of electrons, whereas a Lewis base donates a pair of electrons. Now let's go back to the question. So in the question, it is mentioned that the coordinated bond is between cobalt metal atom and NH3 ligands. So we can rule out chlorine as one of the answer. Let's draw out NH3 as an individual molecule and fill out all the valence electrons. And we can see there is a pair of electrons that can be bonded in a coordinated bond. Therefore, NH3 can act as a Lewis base because it has the ability to donate a pair of electrons. And a faster way to remember this is the ligands always act as a Lewis base. NH3 is donating a pair of electrons to cobalt metal atom. So cobalt is acting as a Lewis acid because it accepts a pair of electrons. The answer to this question is A. The cobalt ion behaves as a Lewis acid.